In this module, we're going to talk about the gypsum plate or the accessory plate. We use the gypsum plate to determine the sign of elongation in a mineral, and we use it to determine the order of interference color that you're seeing in a mineral. We also use it to determine the optic sign, but we haven't covered that yet. I'll show you how we determine the sign of elongation and how it will help us to assess the order of birefringence. The accessory plates are usually made of gypsum that have a known retardation of 550 nanometers. And the orientation of the gypsum is also known. It's set at 45 degrees to the lower and upper polarizer. And the fast ray in the gypsum is parallel to the length of the holder, and the slow ray is perpendicular to the holder. Remember that I said that in anisotropic minerals, light is split into a fast and a slow ray. Those are the fast and slow rays that I'm talking about. The interference of the accessory plate either adds or subtracts from the retardation of the mineral. So if the slow ray of a mineral is parallel to the slow ray of the accessory plate, the birefringence increases. If the slow ray of a mineral is parallel to the fast ray of the accessory plate, the birefringence decreases. So what you get out of this is the accessory plate is going to tell you the orientation of the fast and the slow direction in the mineral. And that's important to identify some minerals. In this diagram, you see there's a lower polarizer there. The gypsum plate is inserted at 45 degrees to the lower polarizer. The mineral that you're studying in thin section has a particular retardation. And remember, retardation results from the difference between the fast and the slow ray. That retardation from the mineral then passes through the accessory plate, and that has a known retardation, and you sum those up to get the retardation that you see with the accessory plate inserted. And if you've got the slow ray in the mineral, look at my pointer there, parallel to the slow ray in the accessory plate, you're going to add to the retardation and you'll get an interference color that is to the right on the Michel-Levy chart. If, however, you have the fast ray of the mineral, I'm pointing to the lower part of this diagram, the fast ray of the mineral is parallel to the slow ray of the gypsum plate, then you're going to get a reduction in the total retardation, and the interference color that you see will move to the left on the Michel-Levy chart. So how you do this to determine the fast and the slow directions in your mineral, you rotate the grain until it's extinct, and that means either the fast or the slow ray is parallel to the polarized light direction. You're going to rotate the stage 45 degrees, pay attention to the interference color that you're seeing, and then insert the gypsum plate and notice whether the interference color increases or moves right on the Michel-Levy chart or decreases and moves left on the Michel-Levy chart. The accessory plate will also help you determine the order of interference color, and that's particularly helpful if you don't have any isochrones on your mineral, on the grain that you're looking at to compare to. You can rotate the grain on the stage with the gypsum plate inserted, and then you'll see the interference color will alternately go up or down one order as you rotate it through to parallel and perpendicular to the slow direction on the accessory plate. If the retardation decreases, the mineral has what's called a negative sign of elongation, or is called length fast. That means the slow component of the gypsum plate has coincided with the fast ray in the mineral. And if retardation increases, the mineral is called length slow, and it has a positive sign of elongation. So if it's length slow mineral, you see an increase in the interference color. If it's a length fast mineral, then you see a decrease in interference color. Now, it's useful, but if you forget and leave the gypsum plate inserted, or you accidentally bump the gypsum plate and it is inserted, your thin section is going to all of a sudden look very pink or kind of violet, and that's not good because then you're not seeing the true birefringence in the minerals, and that's going to prevent you from actually correctly identifying the minerals. So remember to take that gypsum plate out after you're done either determining the sign of elongation or checking the order of interference color. All right, what you learned was that the gypsum accessory plate has a known retardation of 550 nanometers, that the gypsum plate adds or subtracts 1 full order of birefringence or retardation when you insert it, and the gypsum plate can be used to determine the sign of elongation, either whether a mineral is length fast or has a negative sign of elongation, or length slow and therefore a positive sign of elongation. So try this in class.